Hey Algebra, we've spent a bit of time working on equations with variables and inequalities with variables and solving for those variables. Today we have a variable in the denominator. So we're going to have to work on solving equations with variables in the denominator. There is a very special issue when you have a variable in the denominator. The very special issue is you are not allowed to divide by 0 in math, okay? You can't. It's undefined. You can't divide by 0. So when we have variables in the denominator, we have to make sure that it does not allow us to have a 0 in the denominator. So for this example, we have to say that, well, in this case, x cannot equal 2 because 2 minus 2 is in fact 0, and that's not allowed. So that's sort of the goal of this lesson. Right, I skipped parts A and B, so don't think that we missed something. I did it on purpose. We have Mavis. Mavis says that the expression 5 over x plus 2 has a meaningful value for whatever value one chooses to assign to x. Do you agree? Well, we talked about it just briefly. This denominator cannot equal 2, so I can't put anything into the variable because I have to stay away from variables that would give me a 0 in the denominator. So right here we can say that x cannot equal negative 2 because negative 2 plus 2 is 0. So I don't agree. Can't do that. Next we have, I don't even know how to say that dude's name. He says that the expression 3x minus 6 over x minus 2 always has the value 3 for whichever value one assigns to x. Do you agree? Well, I don't agree. So, because if I put in a 2 for x, that gives me an undefined equation, right? So I cannot have the value 2 as part of my solution. But anything else I put in for x will give me the value of 3. Let's try, I don't know, x equals 4. 3 times 4 minus 6 over 4 minus 2. 3 times 4 is 12, minus 6 is 6. 4 minus 2 is 2. That does give me 3. Try x equals 0. 3 times 0 is 0, negative 6. 0 minus 2 is negative 2. It gives me 3. But I cannot use the value x equals 2 because that would give me a 0 in the denominator. All right, a few exercises. Rewrite 10 over x plus 5 as a compound statement. That just means that we're going to write, I've got 10 over x plus 5, and to make it compound, I have to say, and x cannot equal negative 5. I take this denominator, and I find out when it cannot equal 0. Sorry, that's a little messy. Okay, minus 5, x cannot equal negative 5. Consider this big, messy one, okay? Is it permissible to let x equals 5 in this expression? Well, yeah. X squared is 25 minus 25 over, let's see, 25 minus 9 is 16 times 5 plus 4 is 9. No matter what I get on the denominator, my numerator is 0, which is no big deal. I just know that my whole equation would be 0 then. So yeah, I can do that. No big deal. Is it permissible to let x equal 3 in the expression? Let's see, 3 squared is 9 minus 25 in the numerator. Denominator, I've got 3 squared, which is 9 minus 9. I just found a 0. And then 3 plus 4. This gives me whatever. I've got a 0 in the denominator, which wipes out everything in the denominator, and I cannot divide by 0. So no, x cannot be 3. Give it all the values of x that are not permissible in this expression. To do this, we look at the denominator. I look at the denominator as it's written. I don't do any funny math with it. And I say that, all right, x squared minus 9 cannot equal 0. X squared cannot equal 9x. Take the square root of both sides. X cannot equal plus or minus 3. Okay, so we got that one. Now we need the other one. We take both binomials separately and find out what they cannot equal. X plus 4 cannot equal 0. Therefore, x cannot equal negative 4. So those are the 3 values, 2 there and 1 there, that are not permissible in this expression. Okay, an example. Consider the equation given. Rewrite the equation into a system of equations. That just means I need to tell when, what values are not permissible. So my system of equations, I've got the original equation written again. And what can't x equal? Well, here, that means that x can't equal 0. And here, if I set that equal to 0, I can say that x cannot equal 2, because 2 minus 2 is 0. So there's my system of equations. Solve the equation for x, excluding the values of x that lead to a denominator of 0. We've had some issues with these. When I've got 2 fractions, you guys aren't sure what to do. If I just have an expression equals an expression without any addition or subtraction over here or addition or subtraction over there, I just cross multiply. I've got 1 times x minus 2 and 3 times x, and then I can go ahead and solve. Divide x equals negative 1. So this is what the solution can equal, so I'm going to do set notation. Negative 1, but x cannot equal 2 or 0. So that really is my answer, all of it. Consider this next equation. Rewrite the equation into a system of equations. I'm going to just rewrite my equation. Equals 5 over x minus 2. So x cannot equal 2. All I did was look at the denominators, which are the same, and said x cannot equal 2. Now I'm going to solve the equation for x, and again, here I've got 2 expressions equal to each other without any terms adding and subtracting between them. So I'm just going to cross multiply. X plus 3, x minus 2 equals 5x minus 2. Cool. Now, crazy enough here, I can take two binomials that I see on the same side, and I can actually make my life easier and divide both sides by that binomial. And I'm left with 5 equals x plus 3. It's a lot easier than foiling the right side and then factoring, which we really haven't learned how to do yet. So minus 3, 2 equals x. So set notation, my solution, and x cannot equal, what happens? Haha, isn't that funny? So really my solution set is no solution. Okay, if my solution set is 2, and I've already said that x can't equal 2, I have no solution. All right, rewrite each equation into a system of equations excluding the values of x that lead to a denominator of 0. Then solve the equation for x. I'm going to take a tad bit of a shortcut and not rewrite the problem. I'm just going to say what x can't equal. I'm going to say that for all of them first so we can get used to that. I'm just looking at the denominator, and I'm going to try to figure out what value is going to make that denominator equal to 0. Cool? Now let's solve it. Again, I've got 2 fractions equal to each other. I'm going to cross multiply. I get x equals to 5. So set notation, I have my solution. Cross multiply, 1 equals 3x minus 15. I just distributed that. Add 15 to both sides. I'm adding 15 to both sides. And then divide both sides by 3. And here's where most of you think, I did something wrong. You didn't. You have a messy fraction. I don't like messy fractions either, but sometimes they happen. So I have a solution. Okay, I'm going to try these next two by myself. You try yours. Okay, cross multiply them. There are some answers. I think I've got a few more. So I'm going to, next slide. All right, these are all still the same, so I'm going to let you try these on your own. Tell me what x can't equal first, and then go ahead and solve for x and see what happens. Okay, push pause and try these on your own. We had some interesting solutions to this one, so check it out. I've got 2 no solutions and 1 all real numbers, which is quite different from anything we've done. So look at them, let me know if you have any questions. All right, a baseball player's batting average is calculated by dividing the number of times a player got a hit by the total number of times the player was at bat. It is expressed as a decimal rounded to 3 places. After the first 10 games of the season, Samuel had 12 hits off of 33 at-bats. What is his batting average for the first 10 games? So we just do 12 over 33, right? Okay, get out your handy-dandy calculator, and that's approximately 0.364. Okay, how many hits in a row would he need to get to raise his batting average to above 0.5? So now we need an inequality, right? So how many more would you have to add to the top and the bottom to get his batting average above 0.5? Okay, let's go ahead and solve that. I'm going to cross multiply and keep my inequality. So cross multiply, sorry I got interrupted again. I have 0.5 times 33 plus x greater than 12 plus x. If I solve this, I'm not going to show you guys the work. I actually get, we're going to go this way. X is less than 9. Now let's plug in a number. If I plug in 8, 8 is less than 9, right? I get 12 plus 8 over 33 plus 8. Okay, go ahead and divide that out. Sorry, 20 divided by 41. I get 0.49. So we actually need a value of hits that is greater than 9. All right, how many at-bats in a row without a hit would result in his batting average dropping below 0.3? So I've got 12, and I'm actually going to do just adding bats on the bottom. That means that this guy has batted, but he's not getting any actual hits. So that's my inequality. All right, cross multiply 0.3 times 33 plus x, can't write, plus x is less than 12. If you go ahead and solve this, you get x is less than 7. Okay, let's plug in a number less than 7. I'm going to plug in x equals 6. So I have 12 over 39. Go ahead and do that division. Sorry, I got distracted again. If we plug in 6, I actually get 0.307, which isn't less than 3. So I actually need numbers bigger than 7 to satisfy my inequality. Cool, that was fun. Good job today.